I am Rafael Matias, and I will be presenting the work that I have developed during my internship, naming it Improvement of the DINASORE Tool for Easy Development of Distributed Systems and OPC Servitization. So let's start by talking a little bit about the DINASORE tool, and we can ask the question, what exactly is it? So according to the description that we also have in our repos wiki and documentation, DINASORE stands for Dynamic Intelligent Architecture for Software and Modular Reconfiguration. It is a distributed platform that runs at the fog computing level, enabling the pre-processing of data using algorithms that are encapsulated inside modules, and that is function blocks. This reply might have helped understanding a little bit of what DINASORE is, but let's ask another question and see if we can understand it even better. So why? Why use the application DINASORE, and why was it developed? Many of us developers, and if there are here, there are also for sure other developers who have faced the issue of code reusability. Basically, you want to use some code that you have developed again in a new context, but there's always problems in that new context. You never develop code, or you rarely develop code that you can just simply copy paste and then it's ready to go and ready to be used. Function blocks that were mentioned in the previous slide eliminate that problem. You can you create those function blocks, they are the code that you decided them to be, and then you can easily connect them to other function blocks, rearrange them however you want, eliminate them, add new ones, and it's much easier to reuse code this way. DINASORE also works in a distributed pipelines manner, and that means that you will be making pipelines of these function blocks connected to each other, and you can distribute them across different devices. So not only your laptop, but if you have a desktop or if you have Raspberry Pis, you can distribute your pipelines across different devices. It follows the IEC 61499 standard, which might help you implement code too, and uses the OPC protocol. Basically, DINASORE runs a OPC server, and you can host there your pipelines and make methods for them. And you can trigger those methods as if you were triggering that pipeline through an actual network address. More on that later. And finally, if any of well, maybe those applications are a bit hard to get started on, and most of them are not free. And DINASORE is easy to get started, as we will demonstrate, and is free. So those are the advantages of DINASORE. And this presentation will mostly consist of the tutorial that we are about to begin. I will be showing you how to set up DINASORE, making usage of not only the official repository of DINASORE, but also the one that contains the function blocks that we at the lab have developed. Of course, you can start by developing your own right away, but if not, you have a library full of these function blocks that you can use. You'll learn how to build a pipeline, how to generate OPC-UA methods, so those methods that I mentioned, and then how to build an OPC-UA method calling pipeline. So we'll figure out what all this means pretty soon. Let's start by opening. I've already cloned all these repositories on my local machine, and I'll be accessing the second repository, the one of the function blocks on Visual Studio Code. As I go through this tutorial, I'll also be mentioning what contributions I've made to the program and during my internship. So let's jump over to Visual Code. And here you have the repository, you have the FBS folder, which contains all function blocks. All the files are here. So there's that, and then there's the synchronization program. I've developed this synchronization program, which basically allows you to synchronize these function blocks to any DINASOREs that you might have installed on any device. So you can have DINASOREs, for example, I already have 3 DINASOREs on my local machine, 3 different folders, but you might have folders on remote devices with which you have like an SSS connection, for example, SSH connection. And for those, you can also add the username and password tags right here. But if not, it should look like this. You only need to come here to the config.json file. You specify the location of where you have your function blocks, so our folder right here. You specify the location of the dinosaurs that you are synchronizing, so the ones that are going to be filled with these function blocks, the location and the address, and the username and password if it's an SSH connection. And then you have the strategy. Currently, there's only one available strategy, which is the wipe strategy. I'm basically telling the synchronizer to delete any function blocks that might still be here on these folders. But if you don't want to do that, you can simply delete the tag or just leave it empty without the wipe word. It's up to you. Let's run the script, and it's as easy as just going Python synchronize, and it should synchronize my 3 dinosaurs without a problem. We can actually move on and start up a dinosaur, and then we'll start building our first pipeline. So let's come here to documents, and let me choose my first dinosaur. All right, running a dinosaur is also pretty easy. You can just run it with Python core main, and it'll be running. The feedback it gives us is not very visual. You'll have a file with the list of errors that you might encounter, but you also have, as you will see later, in the server, in the OPC-UA server, you have a list of these errors as well, where you can check them. But yeah, so let's start making our pipeline. In order to build the pipelines, we use a program that's called ForDiac. And I'll just briefly show you one other step that you need to take in order for ForDiac to also know where the function blocks are. By the way, this tutorial might have quite some steps to it, but everything is very well put in the documentation of each repository. So if I'm speaking too fast, maybe because there's a lot of content to cover, or if something's missing, you can always check the documentation and everything will be there. There is a library folder here on ForDiac, on your ForDiac installation, and you can simply create a folder called FPS or whatever name you decide, and just clone the repository right here. It's as easy as that. There's no problem with it, and ForDiac will automatically find these function blocks that you can start dragging and dropping on what we'll see now, the app view. So let me fire it up. And we're using version 1.11. I suggest you use that as well when following the tutorials, because the tutorials were made using this version, so it's easy to follow. Let's just create a new system, and we can call it tutorial. And you have this app view where you'll create the pipelines, but you also have the system configuration where you depict the characteristics of your system configuration. So we are working on a PC. You need to add this mres property, then you connect it to the network, and now ForDiac knows what the system looks like. So let's make the pipeline. We can come to the FPS folder. We have all the function blocks that we need, and we're actually going to start by creating a pipeline that simply generates 2 random numbers. So here's the function block. Each function block always has inputs and outputs. And here the input is the range. So I'm going to want to be generating numbers that go from 0 to 9. And we have the outputs where our random numbers will be. This pipeline is as simple as this. There's nothing else. It's made up of only one function block. We'll make pipelines that are longer than this, but still, you'll understand the concept behind a pipeline easily with like this. We can map this to the device that we have told ForDiac before. And it's good to be monitored and watched and tested. So let's do that. Let's monitor the system. Let's watch these values so that we can better understand what's going on. Now we get feedback on their values, and let's deploy the pipeline. So we can make sure here that we are sending it to the right device. So it has been deployed. Everything should be working fine. So a pipeline, basically you trigger one of its events and it will trigger other events showing their outputs, and each output is used for the next one's input. If we go over here and we press trigger event, the event was triggered with the number of 1, and 2 random numbers were generated, 8 and 6. And so here you go. It's your first pipeline. You've made it. Let's go to the second point, which is generating OPC-UA methods. So methods that you can check out on the OPC-UA server that is running with each Dinosaur. Just come over here to the OPC-UA folder and grab an info wrapper. As the name suggests, you need to wrap your pipeline or a section of a pipeline with it. So we can connect this event to the event that we want to trigger. So naturally, we want to trigger the run event. And you can connect this event to any of the ending events of your pipeline. Let's map it as well to our device. And let's give a name to this method. So maybe gen for generate. And it should be working fine. Let's deploy it as well again. And you can redeploy as many times as you want, pipelines, and the Dinosaur is always running. And let's check it out with a OPC-UA client. We are using Prozis to check this out, but you are welcome to use any client that you want, as long as you're able to access a certain address and see the properties of the server. By default, Dinosaur runs on port 4840 for this server. If we connect, we can see that the server is up. We just check some security things. And here we can see the configuration of our Dinosaur. This is something that I also spent some time on during my internship, which was organizing all these folders and information. We can see the function blocks that make up the pipeline. We can see the events and the variables and their values. You can check, do some hardware monitoring, so see how much CPU memory is being used. You can also check the errors that have been produced, and you can check the methods. So here we have our gen method. We can see the inputs and outputs, but let's actually call it right away. So when I call the method, I need to specify the value for the event that I'm triggering. So we'll do it just as for the act did. We'll trigger it with 1. And everything should be working fine. We just generated 2 random numbers, 2 and a 1, and yeah, through an OPC-UA method. So OPC-UA methods are seen. Let's actually try to call these OPC-UA methods through our own pipelines, because if we can do that, then we can encapsulate as many pipelines and sub-pipelines and whatever in OPC-UA methods. And each method calls a pipeline, and other methods can wrap them, and it unlocks a lot of potential. So let's try and do that. We're going to create another pipeline similar to this that concatenates 2 inputs as strings. So if it receives 2 numbers like this, 2 and 1, it will generate the string 21. That's called concatenate str. And let's grab an info wrapper. And let's connect it as we did with the other one. And actually, before we move on, let's also fire up two more dinosaurs that we are going to need. So let's just open new Windows, open the dinosaur, and fire it up. So it's as simple as running the same command, although we need to change the ports. Naturally, the other ports are already being used. So this one is actually going to use 61500 to communicate with 40ac, and the server will run on port 4841. You just need to update those flags and it'll be fine. Now we need the third and last dinosaur. So yeah, here. And just as we did before, let's just increment by 1. So Python core main, and we can do -b 61501 -u 4842. Okay, now everything should be working fine, and we have 3 dinosaurs running. Let's tell that to 40ac. We can move this one over here. Let's repeat the process for 2 more other devices. So don't forget to change 61500. And 1 final dinosaur running on 61501. All right, and all connected to the network. So now we can map this to the second device. Let's give this a name con for concatenate. All right, and now let's see how can we call these methods. I'll push this over here even. Actually over here. So you have a function block that, as the name suggests, calls methods. It's the method caller, okay? And it's as easy as just specifying, so we want to trigger the method called gen, and the server URL, I already got it here, so it's easier. just copy it, but you know which one it is. It's at localhost 4840, and we're going to trigger that method with a 1. And let's just grab another one and make an actual pipeline with multiple function blocks. So naturally, the first input, the first output will be the second's input. So we connect it like so. The run output will trigger the second's function block, so no problem there. This one is going to call the method name con and similar address, but for 841. Let's grab it to here, it's prettier. All right, let's trigger it with the input event of 1. And let's also wrap this with an info wrapper so that we can call it on Prozis and we can better visualize it. We can map it to our last device, and this should be working without a problem. Let's deploy all 3 of our pipelines. As I said, you can deploy and redeploy as many times as you want. And let's check this out on Prozis. Let's connect to the last one straight away. So for 842, none. Okay. And now we see that we have a new method. It's called info wrapper because I did not name it. So it defaulted to the name of the function block, but I could have also named the function block right here. Let's call it. So as you can see, it asks for this input variables field. And that's because I didn't fill it in ForDiac. That's also another functionality that was developed. It's not asking for these server URLs because that information is already being told to ForDiac. Dinosaur detects that and doesn't do anything else, but it didn't detect the input variable, so it's asking me to tell him. Naturally, the input variables are going to be the range for the first function block. We know that it's 10, but if it were more inputs, we could add them like so, separated by commas. It's just a 10, so we can even delete the brackets or keep them. It's up to you. And add a 1 to trigger the method caller with, and let's call it. So as you can see, the first method caller returned the 2 random numbers. The second method caller concatenated them, and 53 became 53. So now, not only do we know how to make a pipeline, we know how to generate OPC-UA methods, and we know how to call them from our own pipelines. Let's go back to the presentation. So future work, what else can be done in Dinosaur? A lot can still be developed. A good first step could be a transparent distributed cyber-physical system. And what this means is that imagine that you want a pipeline to be distributed across different devices. So the very same pipeline, not different pipelines like we did, but the same pipeline across different devices. You need what are called service interface function blocks. So MQTT brokers to communicate via MQTT with other devices. And the first functionality that we could develop would be to, sorry, it says I have bad network quality. I hope you can still listen to me. So that each dinosaur could still communicate to each other without the need of specifying those function blocks on ForDiac. Then we have the problem of task resource allocation. So one of the big advantages of Dinosaur is really that you can use different devices. You can use a laptop and a Raspberry, like I said in the beginning, all running the same pipeline because of the transparent distributed cyber physical system. With different resources, of course, comes different execution times. So if we want to optimize the execution time of a single pipeline, we need to adapt and see, okay, this device has this many resources, it's better suited to run this function block. So it can make these adjustments while it runs the pipeline, and after multiple runs, it will have enough data to adjust and look for optimal solutions. Or even after enough iterations, we can actually use some hypermodeling and imagine that a new device is added to the system. Then the Dinosaur could somewhat predict what would be the best function block to add to a device that has that many resources based on previous practice. And finally, we could work with time and resource restrictions. So maybe our user wants the pipeline to run under a given amount of seconds, like 5, but any solution that's under that time frame, it's fine. So Dinosaur could go and try to save as many resources as it could under that time frame, so that you can run other pipelines in parallel without wasting too many resources. So that's it for my presentation. Thank you for everyone. Thank you to everyone that's listening, and a special thank you to Professor João Reis, researcher Eliseu, and Professor Gil for making this internship possible. And I will be replying to any questions that you might have now.